मैं घर पे हूँ अहमद, तो मैं बैकग्राउंड ढूंढ रहा हूँ कौन सा अच्छा बैकग्राउंड में।
You will be live on YouTube now, Mr. Om Prakash.
सर अभी से
हाँ, yes.
चालू कर दें?
नहीं, आपको इमेज शेयर कर दीजिए, मैंने लाइव कर दिया है YouTube पे। आप
जस्ट
बाद में देखिए, ओपन कीजिए।
मैंने तुमको एक भेजा है अभी अपना WhatsApp के ऊपर।
हाँ मैं देखता हूँ प्रेजेंट
इंट्रोडक्शन के लिए।
सर आप विजय सर एक चीज पूछी थी मुझे,
हाँ
जब मैं मैं वहाँ पे एंड करूंगा फिर सर कर पाएंगे ना लाइव?
हाँ,
नहीं मतलब
यहाँ
वो
सब
क्या
लाइव हो गया है, इट इज लाइव नाउ, यू कैन स्टार्ट नाउ।
अकबर सर दिख रहा है ये?
Yes.
पंपलेट?
Yes, it is visible.
ओके, लेकिन अब इसको हटाना होगा तो कैसे हटाऊंगा, मुझे समझ में नहीं आ रहा। ओके, तो पहले मैं यहाँ से जब डिलीट करूंगा उसके बाद फिर आप करना है ना? इसमें तो आपका बहुत बड़ा रिज्यूम खुल गया।
मिस्टर ओम प्रकाश, यू आर लाइव, यू स्टार्ट इट।
सर लेकिन लोगों को 4 बजे का दिया है टाइम।
डोंट वरी, यू कैन स्टार्ट द इंट्रोडक्शन।
ओके,
और ओके, लेट मी स्टॉप, ओके?
यस सर।
You can check your YouTube channel also. Open the YouTube channel in the other window, so you can see the comments.
ओके, डेफिनेटली।
Yeah, it is coming.
ठीक है। अगर मैं कॉल कर रहा हूँ है ना, उठाना है क्या? वहाँ से म्यूट कर दो, उठाना है।
Please mute your audio if you are not talking.
ओके सर। शेयर आ रहा है मेरा इमेज? इमेज शेयर है अकबर?
Omkar ji, you please start now.
Okay. Okay, good afternoon, everyone. We are live again here, and today we have our eminent personality with us, Dr. Akbar Ahmed, the senior member of IEEE, having experience of 13 years in the industry, teaching, and the research. Dr. Ahmed has a more than 35 publications in the national and the international journal. He won an award of worth rupees 25 lakh for 10 for 10 in the Typhoon HIL in 2019. So we are happy to you have here Dr. Ahmed. Now switch to the Dr. Ahmed, sir. Sir.
Thank you, Mr. Om Prakash, and giving me this opportunity to present the area which is called as hardware in loop technology and its boon during the COVID situation. Presently, all of us know that we are suffering in academia because we do not have the access to our laboratories. So what can be the most suitable solution for that? I will provide you some of the details of the software which can be used from your PC, and you can convert your PC into the laboratory, and how simple it is and how difficult it is. So basically, as I have been told that majorly the participants are from UG, so I will try to start from the level of the UG and take it to the level of the research scholars. So I hope my presentation is visible to you. So to start off with this topic, hardware in loop technology, is it really a boon during the COVID situation? As we can see that mostly teachers and the students are operating from their homes, so it is difficult to cover the portion of the laboratory part which we need to implement during the conduction of the normal days. So this option can be sorted out by some of the simulation environments, and its result can be visible, which is very, very good. So I'll just share. So first of all, basically the term hardware in loop, it creates a lot of ambiguity in the mind of the undergraduate student that what is hardware in loop. So starting with that, I'll just clear out that hardware in loop, it is a simulation. It is a technique that is used in the development and testing of the complex real-time embedded systems. HIL simulation provides an effective platform by adding the complexity of the plant under control to test and perform. The complexity of the plant under control is included in test and development by adding some mathematical representation of all related dynamic systems. These mathematical representations are referred as the plant simulation, and the embedded system to be tested under this which interacts, it is called as the plant simulation. The next thing is that how my HIL works. Basically, a HIL simulation must include the electrical emulation of the sensors and actuators. These electrical emulation acts as an interface between the plant simulation and the embedded system which is under the test. The value of each electrically emulated sensor is controlled by the plant simulation and is read by the embedded system which is under the test using the feedback loop. And in this manner, the embedded system under the test implements its control algorithm by giving the output to the actual control signals. The changes in the control signal results into the change in the variables, which gives the value to the plant simulation. So, considering the example of this HIL situation, the HIL simulation platform for the development of the automotive anti-locking braking system may have the mathematical representation for each of the following subsystems in the plant simulation, such as the example of vehicle dynamics, in which we check for the suspensions, wheels, tire, roll, pitch, yaw, dynamics of the braking system, hydraulic system, and the road characteristics. The next portion is the uses of the HIL technology. So some of the students might be uh, thinking that how does this HIL technology supports my career? So let me tell you that this HIL technology is effective for all mechanical and electrical and electronics engineers whosoever are pursuing their interest in the area of the research. This platform is just made for you, and you can implement your own ideas in the form of simulation and test it in the form of hardware using this technology. So the uses of HIL technology, basically why it came in picture, is that in many cases the most effective way of develop an embedded system is to connect the embedded system to the real plant. In other cases, the HIL simulation is more efficient. The metric of the development and test efficiency is typically a formula that includes the following factors such as cost, duration, safety, and feasibility. So thinking about each one first, if we will take the parameter of the cost, first of all, the cost of the approach should be the measure of the cost of all the tools and the efforts that you're putting into produce the item in the market. So the duration of the development and the testing affects time to time market for the plant product. Safety and development durations are typically equated to the cost measures. Specific conditions that warrants the use of HIL simulation includes the following, such as enhancing the quality of the testing, giving the tight development schedules, meeting the tight development schedules, high burden rate plants, and early process human factor development. So coming to the next slide, topic, we will discuss this first, and then I'll show you some of the examples that how the HIL is really useful for all of you. So HIL enhancing. Usage of HILs enhances the quality of the testing by increasing the scope of the testing. Ideally, an embedded system would be tested against the real plant, but most of the time, the real plant itself imposes limitation in terms of scope of the testing. For example, testing an engine control under a real plant can create the following dangerous test situation for the engineer, like testing at or beyond the range of the certain ECU parameters, testing and verification of the system at the failure condition. And in the above mentioned test scenarios, HIL provides the efficient control and safe environment where test or application engineer can focus on functionality of the controllers. So solving the tight development schedules, we can have the parallel processing if we are using a HIL. So this can be explained as the tight development schedule associated with most new automotive, aerospace, defense programs do not allow the embedded system testing to wait for the prototype to be available. So in fact, in most of the development schedule assumes that the HIL simulation will be used in parallel with the development of the plant. So this illustrates that multiple modules will be created, on which we will be working on the same time, and the results will be coming in the parallel profile. So, for example, by the time a new automobile engine prototype is made available for the control testing, 95% of the engine controller testing will be done, and that can be used by using the HIL environment. So again and again, I'm using the abbreviation HIL. So it means that hardware in boot. So the aerospace and defense industries are even more likely to impose a tight development schedule. Like the aircraft and the land vehicle development programs are using developed desktop and HIL simulation to perform design, test, and integration, which has to be done in parallel. So high burden rate plant, in many cases, the plant is more expensive than a higher fidelity the real-time simulator, and therefore has a higher burden rate. Therefore, it is much more economical to develop and test while connected to a HIL simulation than the real plant. For the jet engine manufacturers, the HIL simulation is a fundamental part of the engine development. The development of the full authority digital engine controller (FADEC) for aircraft jet engines is an extreme example of a high burden rate plant. Each jet engine can cost millions of dollars. In contrast, a HIL simulator designed to test a jet engine manufacturer complete line of engines may demand merely a tenth of the cost of single engine. So uses in the various disciplines are, we can have several usage in automotive systems. You can see in the development of the radar system. You can have its usage in robotics, power systems, power electronics, and offshore systems. So basically, now I will take the example of the hardware in loop using the platform which is called Typhoon HIL. So here we can see that a user PC and a target PC is there, which is generally connected together, and target PC is used to implement the design that has been done into the simulation platform, and that can be interacting with that will be directly interacting with the actual controller. So there is some confusion in the undergraduate students while I was delivering this lecture, that how all these things are running in the same environment, and is there any other platform on which this hill can be performed. So the answer is yes, there are some other platforms also, but those platforms comes with a big price. So coming to the comparison portion, the comparison of the hill platforms with the other platform, I'll suggest that the Typhoon HIL platform is much more friendly with the user interface. It is very good for the students because it supports the student user through the HIL Academy, which I will cover in the later portion. I'll show you how does it cover that HIL Academy and how you can be certified. So first of all, starting the comparison of the Typhoon HIL. Typhoon is basically it's a company which was established in the Switzerland, and they manufacture the own product line. But the best part is that they provide the software for free of cost for all the academician and the students. So under this lockdown duration, this is the best duration of time when you can explore the Typhoon HIL capabilities, and you can use the platform, and you will really find it nice. So let me compare it with the other platform. So there are certain parameters on which we compare this HIL platform. That is, first of all, is the software and the hardware integration. Second is the forward compatibility. Third one is the model compilation time, processor type, processor utilization, simulation time steps, digital sampling resolution, ease of use, and the technical support. So basically, in the base, considering each point one by one, we'll discuss that how Typhoon HIL is a better platform for the user in India and outside during this COVID situation. And software and hardware integration, it is vertically integrated, means that it has its own platform which supports its own infrastructure also. And now there is one paper which is recently published by Dr. S. M. Tripathi from KNIT Sultanpur. He has developed the PMSG model using the Texas Instrument microcontroller interfaced with Typhoon HIL. So this thing is already there, and it can be supported with the third party devices also. While I'm considering the other platforms like DSpace, RTDS, or MATLAB, they compulsorily require the MATLAB or its tool, which comes with a great price, which is very costly. So the first and foremost thing, it is the hardware and the software integration. it provides vertically. And the next thing, which is the forward compatibility. So it is completely compatible, while the other platforms, they are none of them are compatible with the selected versions. As the versions will change, the compatibility will effectively change. And then next is the model compilation time. Whenever you will use this Typhoon HIL platform, you will see that the compilation time is very, very less. It is very fast in compilation. It usually takes less than 1 minute or less than 2 minutes to compile the whole model and the plant under the testing, while the other platform takes usually more than 15 minutes of time to compile and implement the code on the controller. The next thing is the processor type. The theory behind its fast nature is the use of the processor. It uses FPGA processor. The FPGA means the field programmable gate array. So FPGA based from entry level general purpose CPUs for slow dynamics, while in other platforms, we need to integrate the FPGA. We can integrate FPGA, but we need to pay the license fees for that, for the purchase of that. So it is already integrated with the FPGA, which comes with the parallel processing feature. So because of that, that compilation time and implementation time is less. So next thing is the processor utilization. So this is a very important point. So if we are having a multi-core processor, and if we are not using that processor according to its capability, then this is completely waste of that processor. Here, the Typhoon HIL, it gives a dedicated compiler, and it gives the model libraries with the firmware configuration, which makes sure that the processor utilization is maximum. And while in other platforms, there are partial or significant resources which are unused or lost in the form of hardware and software integration. Next point is the simulation time steps. So this point shows that how fast the simulation time steps can be. So we can bring that simulation time steps to 500 nanoseconds, while in other platforms you cannot go beyond 10 microseconds. So you can see that it is very, very fast, because it is going in the range of nanoseconds. And digital sampling resolution, it's up to 20 nanoseconds, while in others we have more than 100, we have 100 plus nanoseconds of sampling resolution. So ease of use, if we'll say that in terms of ease of use, the embedded HIL provides it's much more easy to use, while in other platforms we need to install the multiple vendors, we need to take the permission from multiple we need to take the multiple tokens from the different vendors, and then integration uses some of the memory that makes the device perform on a slower rate. While in Typhoon, since it is vertically integrated, so it takes lesser time to integrate and perform the task. While in technical support, if we are talking about, we have a very good technical support team in Typhoon HIL, and while in other platforms, all of them are having a different support system tool. And suppose you are stuck to the one problem, sometimes you're not able to get the solution for many months. But here, a dedicated team is working, which is day and night working in the area of the Typhoon HIL. And I appreciate their help, that they immediately respond to your queries, and they will come down to your solution as soon as possible. So the Typhoon HIL, now let me switch over to this Typhoon platform. So the Typhoon HIL technology, it uses the FPGA solver, a specialized proprietary FPGA-based multi-core processor, which is optimized for time-exact simulation or electrical domain models. Typhoon FPGA solver executes model with the base simulation steps, integrated with the industry performance per watt 28 nanometer programmable logic, achieve power and performance level exceeding that of discrete processor and FPGA systems. system CPUs, if we are talking about that, one or more general purpose processors that are indirectly controlled by the users are utilizing this. They are typically used to simulate low dynamics phenomena of certain electrical domain component or handle communication protocol stacks. So user CPUs, if we'll discuss about that, one or more general purpose processors that are under direct user control. They execute submodels composed of the signal processing components, the time steps, and the multiple base steps, which can be defined by the user. So, discussing about the FPGA solver basics, the FPGA solver computational elements are depicted in other functional elements, are omitted for simplicity, and the architecture is scalable and is used on Typhoon HIL device, where it is available in a number of different configurations in order to make the best use of available FPGA sources. Configurations are tailored for specific application domains, and they differ in number and size of the computation. So here in the diagram, you can see that a SPC array is shown with an interface with the signal generator, LUT, machine solver, and PWM modulator. So all of these things are parallel processing, and because of that, we have a low latency interconnect, while we have some latency developed in the other platforms where the integration is not parallelly done. So vertically integrated solution, it means that it provides the software and the real-time simulator in the same time of the same make. So here in the software, we have basically five portions which we need to discuss. The first one is a script editor. In script editor, you can code. You just need to have the basic information about the Python language. You can implement your code by using the script editor, make the model, and that model can be used in conjunction with any platform, especially in the platform of the control HIL. The next is HIL Control Center. HIL Control Center, basically it contains all the basic inputs and the features that is there in the HIL platform. It has the control panel on which you can directly change. You need not to stop the simulation. You can directly change the set of inputs and variables, and its effect will be visible to you on the screen and in the hardware platform. So here we need to understand basically the difference between the simulation and the real-time simulation. So basically, the simulation is the imitation of the mathematical model that you are using and the output of that. But the real-time simulation means that it is the imitation of that model with respect to the change of the dynamics of the input that we are having and the input and output both. So basically, the real-time simulation shows that if we have a rapid change in the input, it should change rapidly with the least time. So in simulation, we cannot stop and change the parameters at the same time. While in real-time simulation, if you take the example of the air missile or the rocket, so many parameters are changing there in the real time that we need to suppose. Let us take the example of a target which is moving and that has to be struck by a missile. So that if the target is constantly changing, so that cannot be emulated in the real time. That cannot be emulated in the normal simulation environment. That can only be done in the real time simulation environment where the dynamics are constantly changing, and you need to understand those basics basically to adapt this real-time environment. So this is one of the statement by Dr. Andreas Dietrich from EnerDrive CEO, and he has shown the laboratory setup on the left-hand side. You can see, so a huge infrastructural setup is required to implement a 700 kVA voltage source inverter for transformer testing. Here we can see that the results are in bipolar situation, and we can see that whole laboratory setup can be replaced by a small box. on the right hand side, which is represented as HIL 400 basic setup. So this whole block can be replaced by a simple box which can be kept on your table, and it can emulate in real time the whole setup of the laboratory that is shown in the left hand side of the picture. So as he has said that the Typhoon HIL emulator with OEM controller makes an ideal development environment which combines real control signals in real time with real hardware, which is as easy to operate as a software simulation package HIL must have for every power electronics engineers. So if we will discuss about the automation, so we need to have this, like first of all, we need to perform the simulation. Then we need to check for the compatibility with the available Typhoon HIL process. And then we'll go for the real-time simulation, which is basically the most uh, demanding situation right now in the current era. So the Typhoon HIL process, it automatically generates the code, it automatically compiles the code, and it automatically loads to the all the dynamics to the plant on its hardware. So the control center, Typhoon control center, as I have already shown that it is comprising of 5 things. First one is script editor, HIL control panel, control center, schematic editor, scope and capture. So scope and capture are generally used to see the waveforms in the real time and how those waveforms are changing. That can be changed by using the HIL control parameter, HIL control panel. From that, we will change the set of inputs, and the change of the outputs can be observed on the scope and the capture screen. So Typhoon HIL in India currently, these are the academic institutes which are using Typhoon HIL, and in industries, GE, Schneider, ABB, and there are many more companies which are now supporting the Typhoon. And this is the global platform on which the HIL is generally used these days. So this I would like to show you that on how the students can use this for learning. So HIL Academy, it is there. You can note this website, HIL.academy. Here you can find many models which will give you the basic understanding from, let us say, the example of the grid tight, or example of the wind power control model, or BSI control model. Many examples are available on this. And there is another link which I am sharing here. It is corps.com/downloads. I'll show you. Once you will go there, you can see once you will open this website, corps.com/downloads, and if we'll go to the download portion, you can see that here I would like to show there is this option which explains that convert your PC into virtual HIL laboratory. So the list of the experiments that can be included is visible in this. So I'll just, for a moment, I'll show you that the engineers and the academicians are working. The group of the Typhoon HIL experts are working days and nights to provide the better platform for the students throughout the country and the world. So meanwhile it is loading, I'll just share another link which is called HIL Academy. So here the first one is HIL Academy. Once you will open it, here you can make your own free login account, and from here you can start learning. So this platform, here you can go to the learning resources. You can find a lot of courses which are available right now. And at the end, There are so many webinars also on which regular webinars are conducted time to time on HIL platform. So meanwhile, I'll show you this, the lab manuals for electrical engineering. Basically, this booklet is uploaded there and it is free of cost. So these are the list of the labs that engineers have developed together to ace your understanding. Almost all the laboratories of electrical and electronics engineering are covered in this. So you can see in this, many experiments are there. Now I would like to show you the real-time model, that how the interface looks like. This you can download. All the students are welcome to join this HIL Academy, and once you will complete the course, you can get the certification from the Typhoon HIL Academy, which will acknowledge your effort to understand the this course. Last year, I participated in this Typhoon HIL award, and I was awarded uh, the device in terms of HIL 402, which worth around 25 lakhs. So this program, basically, this year it is now closed. So they are motivating the users from time to time, and they are giving a free tutorials also, which you can see on this website. So it is opening now, Typhoon HIL Control Center, which I clicked on. So you can simply make your login on Typhoon HIL and download this file based on your requirement, and you will get the so here, as I've earlier mentioned, that it consists of the free, basically 3 or 4 modules which are there. So once you will click on this HIL version, you will get to know about the version details. Then this is the basic. This is the basic. Here you can see that this is the basic input section where we can see what all things are there in HIL Typhoon HIL Control Center. So the first one is schematic editor. If we'll go to the schematic editor, we'll see that certain options are given. So let me cover this. If the time permits, I'll go and I'll show you one by one. Then there is some waveform generator, there is signal generator, script editor. As I earlier told, in the script editor, you need to write the model in terms of. So here we can see that this is my. And once I'll start making the new schematic wizard, I'll just choose here HIL 401. I'll choose this as the setting, and now I need to click on next and finish. So it should automatically open the new model. These are some of the inputs which are given there. For compilation of the program and compilation, we need to click on this downwards arrow. It is presented over there. The next portion is HIL SCADA. So here we can see that if we want to check the inputs, we have the macros, we have the buttons, text boxes, combo boxes, check boxes, slider, knobs, and for monitoring, we have the gauge, digital display, text display, LED, trace graphs, XY graphs, phase graphs, PV monitor. So let me click on this. Capture scope. So this is basically HIL SCADA, which is available in this portion. And then we have Typhoon. Then we have Typhoon Test IDE. You can check this that in the documentation hub, you will here find out the manuals which are there for the user for starting their journey on Typhoon HIL. It is very simple, and you can utilize this anytime. Meanwhile, now I'll show you the signal analyzer. How many kind of signal analyzers are there in this? Unfortunately, because of the slow speed of my laptop, it is taking a lot of time to open up because my RAM in this laptop it's 3 GB, so which is very less. I prefer more than 8 GB or 8 GB RAM or 4 GB RAM also could have done it. But in all those machines, if you are having a good RAM, you can definitely use it on a faster scale. So let me show you this PV module modeling and application. This example, and then I'll show you one of the running in the real-time environment. So basically, making a PV module, it's like a current source. I think I need to close this first, and then I'll show you. Yeah. This PV model, this equation, the equation of the current, this is represented in this manner, that this is the voltage curve for fixed temperature irradiance. So here we can see that there is one point at which the peak is 220 watts of power. It is available at this point. So this point is called maximum power point, and this is IV curve in the blue line. You can see that this is called IV curve, and we can see that this MPPT, it's a big problem for our electronics engineer to track. If we will not track this MPPT point, ultimately this keeps on changing with change in irradiation and temperature. As we can see that it is totally dependent on temperature here, TC, and because of that it is constantly changing. And the real time example which I'm going to show you now is this only. So video. So under the uniform insulation, this video has been taken from the real time with the Agilent solar PV emulator. Here you can see that the yellow portion is showing that we need to trace that point, which is called maximum power point, and the cross portion, which is constantly moving left and right, it is showing that it has traced that point. So once it has traced, and we can see on the right hand side top corner, the MPP percentage of tracking here, it is now 99% something. So we can see that this point has been traced very efficiently with 99% of accuracy. And now at this point we can see that the voltage is somewhere around, the current which is somewhere around 2.25 amperes, and the voltage should be somewhere around less than 40 volt, 38 or 39 volts, like that. So now I would like to show you the hardware on which it is implemented. So here, this is the screen of the DSO, sorry, which is showing you the PWM, which is changing constantly here. This is narrowing down, and we can see that the voltage is now getting changed, and now it is getting to a fixed position. And here we can see that this portion here, average voltage is now somewhere around 38 volts. So this is the hardware on which this has been developed, which is working in real time in conjunction with controller. So I hope the session was helpful to you, and these are some of the models which are there in the schematic editor. You can see here, you can use this like this. You can simply drag and drop. These are the screen. These are the things which are available on the schematic editor. You can simply drag and drop. You can draw the models which are there, as I have already shown these things on, and I have given you the reference also. If you are a beginner, you can go to this website and you can start implementing and start getting the taste of hardware in loop technology, which is currently the basic requirement for a power electronics, power system, mechanical engineers, because it saves a lot of money before going into the development phase. So with this, I would like to end my session, and I would like to see if some of the questions are available.
Doctor sir, we have one question from the Raghavendra Pal Singh. He is from KK Wag, Institute of Engineering, Nasik. He want to ask that if we have to be a start from the scratch,
Yeah.
Which basic courses or resources can we use to?
Okay. So, who is that person who's asking? Can you please repeat?
Raghuvinder Pal Singh.
Raghvendra Pal Singh. Okay, Raghvendra, you can access this website which I have shared, HIL.academy, and here you can go to the courses portion, and by looking at these courses, you can browse the interest of your own, and you can see many tutorials are given, and from there you can choose how you can proceed further. And the second link which I have shared is this one, carbs.com/downloads. From here you can see that I've shown this earlier also. Around 19 laboratories are already developed over there. So you can use that for upgrading your skill. I hope I've answered that. Next.
We have Mr. Mayank Dwivedi. He is not mentioned his location right now, but he would like to ask the real-time example, some real-time example of this.
Real time example right now, if we'll take the case of uh, electric vehicles, you can implement the electric vehicle, you can design the motor, you can give the parameters of that motor and check for the torque and speed of that motor in conjunction with the battery. How is it charging, discharging, SOC, everything you can monitor in real time. Another example, you can see the grid tied inverters with solar photovoltaic inverters. You can see the PMSG modeling in the wind. You can implement all these models on the real time, which you cannot be seeing uh, just which is not available for the students. So it is a good platform to learn, to do the mistakes, and again relearn and implement it.
Okay, okay, that's good. Doctor Sir, I have one doubt. Being a mechanical engineer, basically we are from the mechanical domain. So these all are the somewhere is going to be relate much more relate to the electrical and electronic field. So how this thing is going to be beneficial for us also?
For a mechanical engineer, right?
Yes, yes.
So basically, I don't see much things apart from electric vehicle. Or can you just give me any example which requires the use of the controller in mechanical engineering?
Basically, we are controller like means we are using the microcontroller, microprocessor.
So
That is
wherever basically the microcontrollers and microprocessors are coming in the picture, you can
okay.
use that here. So let me give you the example of the turbine control. If
Okay,
you're controlling the turbine, uh,
okay,
hydro power plant, or you are controlling the turbine, you want to see the characteristics of those turbines. So those things can be implemented in this platform.
okay. Actually, we know that the whole world is going to be running toward the multidisciplinary act, like IoT is there, AI is there. So in the similar way,
Yes.
and we are going to be use this the process, this principle for the as you mentioned photovolatile cells in the solar cell also in the solar plates, solar gadgets.
Yeah, yeah. Same.
Okay, that's good.
One more thing, one statement I would like to give before ending the session,
Mhm.
that we have been seeing the word which is called as Industry 4.0 for last 1 or 2 years. It is booming in the internet, Industry 4.0. But
Okay.
let me tell you, my friend, now that Education 4.0 is the new thing which is going to change this sector from now onwards. Due to the COVID situation, the sector of education is now changed to Education 4.0, and we are much more dependent on the virtual environments now. And because we require such environments, in a day you can see that the people started using Zoom and Google Meet and everything. We were not using it earlier. But this platform, HIL platform, the limitation that we are having, that we cannot use the laboratories during this COVID situation, this can be replaced by this. You can directly simulate it, and get the result. and education 4.0 can be directly integrated with this hill. That with this, I would like to give the closing remark on this.
Oh, okay. Is there any implementation in the smart grid also?
Excuse me, pardon me.
Can we going for that some implementation in the smart grid?
Yeah, in the smart grid, basically, as I told that in smart grid, you will require different DG, the distributed generation, and the controlling of those distributed generation resources are very complicated. So that has to be done on the real-time platform. So for performing that smart grid operation, also you can code in the test schematic screen, and you can implement that model of the smart grid. It is, I think, some of the models are also given in their hill academy also. So that is a wonderful platform to learn.
Okay, okay, that's good. We have one more query. Mr. Rajesh want to know, can we download software free of cost?
Yeah, the software is totally free of cost. So it will not cost you anything. You just need to register on the website and you can download it. I think this software is somewhere around nearly 900 MB. And after that, you can make your laptop or PC a virtual hill device.
Okay, it is beneficial for the academicians also because we are going to be
Definitely, definitely. This is much more efficient, means it's much more beneficial for the academicians because this is the only tool which is giving us the freedom to stand at par with the industrial experts. So whatever they are speaking, we can simulate that in our labs and we can show to the students that this is the requirement these days and how we need to address those requirements.
okay. Which software you're using for that real timing parameters, showing the real timing parameters? Which software?
HIL, this Hill Control Center, Typhoon HIL.
Okay, okay. Getting it.
This is the screen which I have shown earlier,
Any
Typhoon
more
HIL.
queries
I
there?
think this will be visible to you now.
Okay, we have Mr. Sajid Ali from Jamia Malia Islamia University. Okay, it's a HIL, is it?
It's, it is HIL.
Okay. So, Doctor Sir, it's really a very good interactive with you. Being a mechanical, but we know that the today whole world is going to be, contributing all the discipline. And on the behalf of that, it's a really worthwhile session for us, and we are definitely going for that. And even it's being a proud for us that we have interacting with the person who is having 10 for 10 awards worth of 25, lakh with us. On the behalf of Professor Imran Malvi, the head of mechanical department, Parul University, and the whole Parul University means family. I would like to say thanks to you for giving us a wonderful session. It's really worthwhil for us, sir. Thank you, sir.
Thank you so much for your time. And all the participants, thank you for joining this session. And special thanks to Dr. Om Prakash for giving me this opportunity. Thank
Still, I'm not doctor. I'm still trying. Okay, sir. Okay. Thank you, sir. Thank you. Good day, sir. Thank you. Good day, sir.